everybody. Welcome to the video here for lesson number 4. So we're continuing our circle chapter here, and we're talking a little bit more about the angles that are created within our circles, more specifically what we call inscribed angles. In lesson 3, we defined what an inscribed angle was, and we were able to come up with a rule for it, and today we're going to play with actual problems that deal with this idea of an inscribed angle. Before we do that, though, let's just kind of review a little bit of vocabulary that we should know, right? So I've given you a picture here in the opening exercise. There's a lot going on here, right? We have diameters, radii, chords, and we even have this crazy line that we haven't even learned what it's called yet, line FE. This is what's called a tangent line. And all this stuff is all just kind of like window dressing, because there's only one piece of this problem in the opening exercise that we care about. We only care about triangle AOB. Triangle AOB, and it might be useful here for you to have highlighters. Triangle AOB is here. Now, what do we know about triangle AOB? Well, we know that AO and OB are the radii of this circle, therefore they're the same size. So what we can say is OA is congruent to OB because both are radiuses, meaning triangle AOB is isosceles because, whoops, I spelled isosceles way wrong, because it has two congruent sides. All the other stuff going on in this picture doesn't matter. I'm only considering that one part of this picture. One of the things that's interesting about the circle questions that you'll see within this chapter, especially as we keep getting more and more rules, the pictures are going to get more and more complex. We have to be able to break the picture down to just the part that we care about. So, right below the opening exercise, there are two little sentences here. This kind of goes over what we're doing in the first part of today's lesson. So it tells us that inscribed angles are angles created with a vertex on the circle, and it's constructed by creating two chords or constructing two chords that intersect each other. And the rule is the inscribed angle is half of the intercepted arc. So taking a look at this first example, the angle ADB of 86 degrees, that's a central angle. We learned in lesson 3 that central angles are the same as their intercepted arc, so arc AB is 86 degrees. Now, if arc AB is 86 degrees, that means we should be able to determine x. And if we're determining x, what we're able to see here from x is we are talking about an inscribed angle. The angle created by x is created by two arcs, two chords, AC and BC. Now, the intercepted arc is the same exact arc. It's arc AB. So if I was to look at this picture without all of this other stuff going on here, like if I had this circle and I just had this intercepted arc of 86 degrees and this inscribed angle of x, we'd be able to say that this angle of x is half of that arc. So I can say angle x is 43 degrees. Because x must be half of the arc. Well, I can kind of do the same thing, but backwards. So here we're given the inscribed angle. 75 degrees is created by two chords. So since 75 degrees is created by two chords, I'm going to highlight the two chords and the arc that inscribes it. Now, the relationship between that little angle of 75 degrees and that arc is the arc is double the angle, or the angle is half of the arc. We can look at it in both ways. So arc AC is 150. Notice we're working backwards this time. I knew the inscribed angle, so I'm able to determine the arc. Now, that's not the thing that they wanted us to find. They wanted to find this central angle. Well, what's special about that central angle, and I'll use a different color highlighter here, is because it's a central angle, it's equal to the arc that inscribes it or intercepts it. So since we have this angle of 150 as the arc, the angle at the central piece of the circle, x, is also 150. So there's a relationship here. When a central angle and an inscribed angle are inscribed or intercepting the same exact arc, they are actually going to be half of one of the other. So the inscribed angle is going to be half of the central angle that intercepts the same exact arc. Kind of a fun rule. You don't need to memorize that rule. That's why it's not written in paper on the notes here. But it is an idea that we can kind of come up with. Let's take a look at exercise 1. So exercise 1 gives us this angle 2 of 42 degrees, and it wants us to find the measurement of arc BC. Now, I can actually find arc BC without knowing much of anything other than there's a triangle here. So here's my triangle ABM. What do we know about triangle ABM? It's isosceles. How do we know it's isosceles? BM and AM are congruent, meaning angle 1 and angle 2 are congruent. So if angle 2 is 42 degrees, that means angle 1 is also 42 degrees. Why is angle 1 important? Well, if I look at arc BC, and I'll use here again a different color highlighter, arc BC is part of an inscribed angle. AC is a chord, AB is a chord. We have an inscribed angle here. So what do we know? We know the inscribed angle is half of the arc, or the arc is double the inscribed angle. So arc BC is equal to 84 degrees. Is this the only way we could have gotten this answer? No, but it is the easiest, quickest way of getting this answer of arc BC. Notice what I highlighted there in green is an example of an inscribed angle, an angle where the vertex, vertex A, is on the circle. Let's take a look at another one. So it says in circle O shown to the right, angle MOP is 118 degrees, and it wants us to explain why angle MNP is 121. So what do we know here about this circle? So we are given a piece of info. The piece of info that we are given is angle MOP. Now, if we were in class, I'd say, what is special about angle MOP? Is it central or is it inscribed? And I would hope that we'd all be able to say that that is a central angle. So what does that tell me? If that's a central angle, that means the arc is the same. So I can say arc M and P, the arc, is equal to 118 degrees. Now there's another arc here, MP, this big major arc. This major arc is going to be the subtraction of 360, a full circle, and the arc that we know. So if I do 360 not divided by, minus 118, we get 242. So the major arc is 242 degrees. Now, the reason why finding this arc is important is they want this angle, MNP. Well, let's take a look. What kind of angle is MNP? MNP. Well, that is an inscribed angle that's inscribed to this intercepted arc of 242 that we just found. So if I look at what's just in pink, that's what we're looking at here. Again, if we just redraw this quick, what we're looking at here is an inscribed angle that's really, really big that goes to this arc of 242. I want to know, well, what's that angle here, right? So we're talking just about this part of the picture. Ignore what's in green. Well, if I do that, I know that the intercepted inscribed angle here, this inscribed angle is going to be half of whatever this arc is, 242. So I could say angle MNP is equal to half of 242. So angle MNP is equal to 121 degrees. Now it does say explain. Whenever I say explain, that means I want words. I want you to write a sentence here. So we can say angle MNP is inscribed to arc MP. That is perfectly acceptable. That's done. Let's take a look at number 3. So number 3 says in a diagram of circle K below, as soon as we see circle K, that tells us K is the center. It says the ratio of arc RT and arc TS is 2 to 7. Oh no, ratios are back. So what that tells me is that RT, the arc, we're going to represent as 2x. And TS, the arc, we're going to represent as 7x. And then see what those two arcs together give me. Did they give me a whole circle? Did they give me a half of a circle? What do they tell me? And by knowing that, I can figure out what x is internally, making sure that I then know what those two arcs are. So TS is 7x. RT is 2x. Now, if I look at just those two arcs together, right, from R all the way around to S, that's a half of a circle. Well, how many degrees is a half of a circle? 180. So I could say one arc plus the other arc is equal to 180. Combine up some like terms and do some algebra, and you get x equals 20. If x is 20, that means arc RT is 40 and arc TS is 140. So we can say arc TS is 140 and arc RT is 40. Then it says, explain why TRS must have the same measurements as TWS. So let's take a look, right? Actually, no, I didn't even answer this first part. It says measure of angle TRS. So let's find where angle TRS is. TRS is inscribed to the arc of 140 degrees. So to find that measurement, right, we can say angle TRS is equal to half of the arc of 140. So angle TRS is equal to 70 degrees. Then it says, why is angle TRS the same as angle TWS? So if I look, TRS is 70. We just figured that out. So what I want to know is, why is TWS also 70? So if I start highlighting, you're going to notice something really quickly here. TWS is in a different location, although it's inscribed to the same arc. So what we can say is they're both inscribed angles. So they're both inscribed to the same arc. All right, let's take a look at the next one. So it says in circle O, what is the measure of angle ABC? Explain your response. So whenever we're asked what kind of measurement an angle is, you have to think, what kind of angle is it? So ABC is this angle. Notice the vertex is on the circle, therefore it's inscribed. Well, it's inscribed to a half of a circle. Even though they don't tell us, I know that a half of a circle is 180. So angle ABC is going to be half of that, so it's going to be 90 degrees, meaning this is a right triangle. We like right triangles. We know so many things about right triangles. We can find the missing sides using Pythagorean theorem, using SOHCAHTOA. All of those fun things come back here. So it tells us that AB is 10, and it tells us that BC is 24. And it wants us to find the length of AC. That's just Pythagorean theorem. 10 squared plus 24 squared is equal to AC squared. So if I do 10 squared plus 24 squared, That gives me 676 squared. So we have AC and square root that, and we get AC is equal to whatever the square root of that number is. So if I do the square root of 676, I think it's 26. 26 is my length of AC. Pythagorean theorem should be something I do not need to teach you anymore. You've been doing it since 7th grade. I know I say that all the time in class, but it is true. Now, the question of this problem here, and the fun part of this problem, is knowing that little bit of information. Now that I know that AC is 26, I have a right triangle. And in right triangles, I can use SOHCAHTOA to find the missing angles or missing sides, given at least 2 pieces of info. I have 3, so I can find a bunch of things here. Now, they don't want us to find an angle. They want us to find an arc. Well, to find an arc, we need to know an angle. So let's take a look. What angle would help us find this arc BC? Well, that would be angle CAB. That angle there is inscribed to the arc that we want. So if I can find that angle, I then can figure out what the arc is by doubling that angle. So if I draw this triangle separately, so if we were in class, I'd say, all right, let's draw this triangle separately, label it ABC, make one side 26, this side AB 10, and this side 24, and I'm going to have you put a little theta symbol here because that's the angle we want to find. I'd say work with your partner or by yourself and try and find theta using what you learned in Unit 6. So, how can we do this? Since I know all 3 sides, I can use sine, cosine, or tangent. It actually doesn't matter. They all will work here. So if I say the sine of theta is equal to the opposite side, the side opposite theta is 24, divided by the hypotenuse in this case is 26. I can then say theta is equal to sine -1 of 24 over 26, because remember, we always have to type something in differently in the calculator to find an angle, right? I know I said that in class. So if I do that really quickly, I'm going to get a hopefully good answer if you're in degree mode. I wasn't. So if we do 24 over 26, you know how to type this in. We've done this before. So we wind up getting 67.3801. Now you might be saying, why didn't you round to the nearest tenth? And that's because that's not my answer. That's just this angle here. To find arc BC, I'm going to double that because the arc is double the inscribed angle. So in my calculator, I'm just going to hit times 2, and I'm going to get arc BC is 134.8 degrees. Let's keep going. So here's what I'd like you to do. I'd like you to pause the video and try exercise 5. Label what's given, take a look at what you know and what you can maybe assume from the picture, and see if you can come up with an answer. It's okay if you can't. All right, so welcome back. Hopefully you tried 5 by yourself. If you were trying 5 and got stuck and you maybe just didn't think that you knew something, there is a rule here on the bottom that you're going to be able to use, but you'll see you don't even need the rule because you're super smart. So if we take a look here, it says angle BCD is 30 degrees. BCD is 30 degrees. It then says, what is angle AOB? Well, you might be thinking there's some weirdness going on here. It tells us that there are 2 sides that are parallel to each other, and then there's this line that comes across. Doesn't this look just like this picture that we did all the way back in October? And the answer is yes. There's an alternate interior angle here. Now, since that alternate interior angle is 30, and this is a isosceles triangle, I know this is also 30. So here's what we have. After dealing with the triangle, we have a 30, and an angle we don't know but we want to know. So if I take 180 and subtract 30 and subtract 30, I get 120 degrees. I get that without having to know this rule that I put below. However, if you know the rule, it makes it a little bit easier. You don't have to think about alternate interior angles, but you know alternate interior angles already, so why memorize a new rule? So although that rule's in the notes here, it wouldn't be one I would expect you to memorize because you already know that alternate interior angles are congruent. All right, let's keep going. It says in exercise 6, AB is parallel to CD. As soon as I see parallel, think alternate interior angles. I don't even have to read anything else anymore. I already know that if this angle is 42, this angle is 42. That is good enough to me. It then says arc AB is 20. So this arc up top is 20. And if this angle is 42, that means this arc is 84. If this angle is 42, that means this arc is also 84. And then we can find the missing arc that we know, right? So it says that they want us to find arc AB, which we did already. It was already given to us. That was silly to put there. But I want to find arc CD. What do we know about a full circle? Full circle is 360. If I subtract the given arc and the two arcs that we found, 84 and 84, that were the same size, I could take 360, subtract 20, subtract 84, subtract 84, and I'd be left with 172 degrees. That would be arc CD. It then says, explain why angle ADC is congruent to angle BAD. We can say they are alternate interior angles. Or we can say they are angles that are inscribed to congruent arcs. Any angle that's inscribed to an arc of 84 degrees is going to be 42 degrees. That's how inscribed angles work. So if we were on a totally different problem with a totally different circle and the inscribed angle was 42, the arc's going to be 84, just the way it is. So since these two angles are inscribed to the same exact size arc, I know that they are going to be the same exact size angle. It's just the way that the parallel lines work in circles. All right, so now that we went through everything there, this is a good time for you to stop the video, try the homework on your own first, see how you do. If you have questions, reach out to me via email. I'd be happy to answer them. All right, so hopefully you watched the video and you are now checking your homework answers. You're not just copying my answers down. So here's the first one. The first one says angle D is 25. That tells me that this inscribed angle is going to become a intercepted arc of 50. And if the intercepted arc is 50, guess what? The central angle is also 50. So in this case, X is 50 degrees. In part B, it tells us that angle B is 32 degrees, which means that the intercepted arc is going to be 64 degrees, which means that the central angle is also 64 degrees. This is an isosceles triangle. So if I take 180 and subtract 64, I get 116. If I divide 116 by 2, I get 58, which means each of these base angles is 58. So for part B, X is 58 degrees. Part C says angle D is 15 degrees. If that's 15 degrees, well, X is also 15 degrees. It has to be. It's the same size because this is isosceles. Now, I could have found the missing arc. I could have said that this is 30, making this 30, making this one 50, and we could get it that way too. But knowing that this is isosceles makes this even quicker and actually a very easy question. Shouldn't even be in here. Part D says angle D is 19 degrees. That's an inscribed angle, meaning that the arc is going to be double that, 38 degrees. Now, if I just take a look at this triangle here, this triangle here has an angle that we know. It has an angle at angle A of 38 degrees. Also, since it's an isosceles triangle, since it's made up of two radii, these two base angles B and C are the same. So if I do 180 minus 38, that's going to give me 142. If I divide 142 by 2, I get 71. So in this case, angle X is 71 degrees. Part E says, explain why triangle ABC in problem 1D is isosceles. This is like the fourth time I've asked this question. It's probably important. Like I would assume on a quiz or something I would give you to assess what you know here about circles, that I'm going to give you a picture. I'm going to say, here's a triangle. Tell me why it's isosceles. And you have to say, because two sides are radii, or the radius, however you want to say it, of the circle, meaning they are congruent. Also, we know that isosceles triangles have two congruent sides. However you're explaining it has to be something valid about circles. So you have to have the fact in there that they're radii before you could start to talk about that it's an isosceles triangle. Okay, important concept. All right, a couple multiple choice questions here. So it says in a diagram of circle M below, it says arc PRQ is 308. So from P all the way around to Q is 308, meaning this little angle or arc, I'm sorry, that's left is going to be 360 minus 308, which is 52 degrees. So this angle here is 52 degrees. And it wants us to find angle PRQ. It's inscribed, so it's half of that. So the answer there is 26. Number 3 says in circle D, angle CAB is 32 degrees. Which of the following is arc AC? This is inscribed, meaning the arc is double it. So that's 64. Don't jump the gun. It's not choice 2. They don't want arc BC. They want arc AC. Well, arc AC is going to be the subtraction of the half circle minus 64. And that's going to be 116 degrees. So they wanted this arc here. How did I know it's a half circle? AD is the diameter. It goes through the center. Number 4 says that the circle is circle K. The measure of NLP is twice the measure of NL. So we're going to make NLX and NLP 2x. So if I go from N to L, we have X. If I go from N to P to L, we get 2x. That encompasses the whole circle. So I can say 2x plus x equals 360, or 3x equals 360, divide by 3, x equals 120. Meaning arc NL is 120, and arc NPL, this huge arc over here, which I'm going to highlight, NPL, this huge arc over here, that huge arc is going to be 240 degrees. And they want this inscribed angle. They want angle NML. Well, inscribed angles are half of their arc, right? That's the arc. So if I divide that by 2, I get 120. Just weird that the answer is in the problem in a different place. Number 5 says that we have a circle. It says that BC is parallel to DE, and it says that BC is 58 degrees. Arc BC is 58 degrees, this arc up top. It also says that arc DE is 142. DE is 142. It then says determine the measure of angle CFE. Well, something that we know. We know this because of the parallelness of BC and DE. This arc is the same size as this arc. They have to be because of the parallel chords of BC and DE. So if I start the problem by taking the total circle of 360, subtract 58, and subtract 142, that's going to leave me with, let's see, 160. Now that 160 is going to be split between both of these arcs. So both of these arcs are going to be 80. Angle CFE, if I follow those letters from C to F to E, that's an inscribed angle to this arc of 80 degrees. So since the arc is 80 degrees, the inscribed angle, angle CFE, must be half of that, so 40 degrees. And again, we use the fact that these are parallel lines here to say that those arcs are going to be the same. Parallel lines are the same distance from each other, so the size of the arc is going to be the same as well. And that's it. That's lesson 4, right? Look for lesson 5 to come out in a couple days so we can figure out and keep moving here with this chapter. Again, if you have problems or there's any issues, please reach out to me so we can kind of fix them before we keep going. This is not a chapter where you could just say, I'll figure it out later. Everything here kind of builds on itself, so make sure that you're watching the videos, rewatching them if you need to, or reaching out to me if you do need help. All right, hopefully I see you soon, and best of luck with circles.